Alright, so today we're going to be talking about transformations with exponential functions. If you haven't put this in your notebook yet, it's going to be exponential functions and the number is going to be 28. So make sure you put this in your notebook as number 28. And really what we're going to be focusing on today is how we take an exponential function and change it by shifting it, and we're going to be focusing on shifts and reflections. So what we're looking at today is we're focusing on the parent function. So the parent function that we're going to be dealing with, or another word for parent function is just basic function. You can write that down if you want to. Just the basic function. The function that is the simplest form that we could have. And today's basic function is going to be f of x, and that's going to be equal to 2 to the x power. So we're going to be working with the basic function f of x is equal to 2 to the x power. And what we're looking to do is we're looking to determine how we change this function based on the information we have. So we're going to add some things to it, subtract some things from it, multiply some things times it. So we're going to do some different things to that 2 to the x power to make it do what we want to in the problem. So the first thing we're going to look at and how we do this is we're going to look at shifting up. Alright, so we're going to look at shifting up. And for this particular problem, I want to shift up, and let's say we shift up 3 units. And you can go ahead and write that down. We're going to shift up 3 units. Shift up 3 units. Now, in order to shift something 3 units up, we've got to kind of think about what f of x means and think about everything that we've talked about in the past. So thinking about the term f of x, we've said in the past that f of x is the same thing as what? Y. Okay? We've talked about that in the past. We said f of x and y are actually the same exact thing. So what we're looking at here, and the reason this is set up this way, is that we're just taking f of x, which is technically y, and saying y plus k, and then changing the y values. Now, when you think about y values, think about this y value for a second, okay? That y value technically means that we're going to go up or we're going to go down. We never go left or right when we're dealing with y values. We always rise or we go down, right? We increase it or we decrease it. We go up or down. We don't ever do anything else outside of that. So when we shift up, it would make sense that we're going to add k, or add the number that we're shifting to that. So in this case, the number that we're shifting is 3 units. So what we do in this case is take whatever the f of x is, and we just add 3 units to the end of it. So the way this is going to work is that you're going to have a function. Now whatever that function is, we're basically going to take and apply the rule f of x plus 3. So when we apply that rule, all we're technically looking to do is substitute in the information we know. So looking at this equation, what do we know about f of x? F of x is equal to what? 2 to the x power. So if we use substitution and take that 2 to the x power and substitute it in for that f of x, then what we find is that our new equation is going to read 2 to the x power plus 3. And if we want to make it an equation, all we got to do is put y equals on the end. Or since f of x is the same thing as y, we could put f of x on the end. But what we're looking to do here is we're looking to add 3 to the end of an equation to make it go up 3. Now understand, that equation can change. We can get different things for different problems when we look at that. So anytime that you see a number added to the very end of a problem, you know that it's going to be shifting up. Okay? So keep that in mind. I know you probably got a couple questions, but let's go ahead and look through all these, and then we'll fix questions at the end. So looking at shift down, let's move on to that one. So let's stay with the same thing. Let's not move too far here. We're just going to do shift down, and let's stay with 3 units. Okay, so here we're going to shift down 3 units rather than shift up. Now, what do you think the difference is in shifting up and shifting down? Rather than adding, we're going to do what? Subtract. Very good. So here we're going to, rather than add, we're going to subtract our k value, which here is going to be 3. So for this problem, the rule is going to read f of x, and then that's going to be minus 3. So that's going to take it down 3 units. So with that rule being known, we know that f of x minus 3 is the rule, and we already know that f of x is equal to 2 to the x power. So we're going to take and substitute in 2 to the x power, subtract 3 from everything, and then add our y equals on the end, and we have our equation. Okay, so we're finding these equations. We're determining what these equations look like based on the information. So if we're adding 3 to the end, we know that we're going down. If we subtract 3 from the end, or my bad, sorry. If we add 3 to the end, we know we're going to go up 3. If we subtract 3 from the end, we're going to go down 3. Now, up and down are pretty good. Okay, there's not a whole lot of questions when you're looking at shifting up and shifting down. They do what we want them to. But the ones that are going to be a little bit different for us here is going to be when we're looking at shifting right and shifting left. Shifting right and shifting left are actually going to be opposite. Okay, I'm going to put OPP for opposite there. And what I mean by opposite is that when you go right, normally you would think to move right, I would do what? If I was going to move to the right, would I add or subtract? Add. Most people would think that. But it's the opposite here. And just take my word for it, okay? Opposite means that it's going to be the opposite sign. So rather than adding, to go right, you're going to subtract. So that's going to be something you got to memorize. You got to know that. To move left, you're going to the opposite, which normally you'd think subtract, you're going to add. So when we have this problem arise, and when we have this come up, let's say we got the same exact thing. We still got 3 units. Okay, we're going to use 3 units for all of these. But in this case, if we wanted to shift right 3 units, then what we would do is we would just take f, and then instead of changing f of x, which is y, we would just change the x values, because x values go left or right. So here are the x values. We're going to take the x values, and we're going to subtract 3 from just the x values. So what that means is that if we have f of x minus 3, then that means we need to substitute in x minus 3 for x. So in our function, we said that we have y equals 2 to the x power. So for x, I'm going to substitute in that x minus 3. So that x is now going to become x minus 3. So when we see something written up with the exponent, we can identify that it's going to shift right or shift left. But if it's subtraction, then we know that subtraction indicates that it's going to shift right. With shifting left, we're going to be doing addition. So with shifting left, we'll be adding that value. So we're going to add it to x. So let's stay with the same one, 3 units. And for 3 units, bless you, for 3 units, we're going to add that amount to it. So here we're going to have f of x plus 3. So we're adding that amount to it. So with this case, same concept, our rule is f of x plus 3 to move it to the left. So here we're going to have the equation y equals 2 to the x power. And then for x, we're going to substitute that x plus 3 in. So this is going to become x plus 3. So with shift right and shift left, the key here is to make sure you understand that we're changing the x. Okay, you're changing the x with this one. As to where shift up and shift down, you were changing the entire value or the y value. So here, focus on the x and then change the value accordingly. But you got to keep in mind, the key here is to make sure you know that they're opposite. So when you subtract, you go right. When you add, you go left. All right, and then the last one we're going to talk about, the last 2 we're going to focus on here in our notes, is going to be reflection about the x-axis and reflection about the y-axis. Now, these are going to make sense because when you think about a graph, if I was to take and reflect something about the x-axis, then that means I'm going to flip it over this line. So if I had a point up here, and I wanted to flip that across over here, then am I changing the x value? Is the x value changing here, or is the y values changing? The y values. Okay, see how this is going from positive whatever to negative whatever? Like if this was positive 3, it changes to negative 3 because I'm flipping the sign. So in order to do that, in order to change it across the x value, I'm going to multiply all the y values times that negative. So in this case, I have the rule negative times f of x. So we've already said that with our basic function here, or our parent function, that we're dealing with just 2 to the x power. So we know f of x is equal to 2 to the x power. So let's just substitute that in. So we're going to have y equals negative, and then f of x is going to substitute in 2 to the x power. That would indicate here that I am reflecting about the x-axis. So when I have a negative in front, it's going to indicate that I'm reflecting across the x-axis. To reflect across the y-axis, I'm going to multiply my negative with my x. So in this case, my rule would be f times negative x, or f of negative x. So to reflect this, same parent function, I'm going to take y equals 2 to the x power, and then for x, I'm going to just substitute in negative x. And that's going to make that equation stick. So with this one, I'm looking to multiply the negative times the x value. With a reflection across the x-axis, I'm multiplying the negative times everything. So what I've got to look for, the key here is focusing on where the negative is being placed. If the negative is in front, then it's a reflection across the x-axis. If the negative on this one is inside or next to the x, then that's going to mean it's a reflection across the y-axis. And if you think about it, it kind of works opposite with these two. If it's affecting the y, it's across the x-axis. If it's affecting the x, it's across the y-axis. So by knowing these rules and knowing this information, you should be able to kind of put together what's going on, and then we can talk a little bit more about the rest after you hear this information. So once you're finished with this, go ahead and close it down, and we'll talk a little bit more about how this is going to apply to you and how you're going to use this in your lesson today.